All right, hello physics students, and welcome to this first screencast by yours truly, Mr. Welch. This screencast is going to be going through unit conversions, and to begin, we're going to be talking about unit conversions within the metric system. It's really important that we know about the metric system because that is the numeric language that we use within physics. It's the most versatile system within the physics or even just the general scientific world. Okay, so what we have here is just a little graphic of kind of some major prefixes and base units within the metric system. And if you take a look in the middle here, I have three base units for the three major physical quantities that we're going to focus on in this class. So what we have here, the base unit for length in the metric system is meters. The base unit for mass in the metric system is grams. And the basic unit for volume in the metric system is liters. Now, alongside here, both on the left and right side, you're going to see prefixes within the metric system. As we move right from our base unit, we are going to be getting smaller and smaller and smaller. Now, there's many more prefixes than just the three listed here, but just know that if we move right from our base unit, we're getting smaller and smaller and smaller. And then if we move left from our base unit, we are getting larger and larger and larger. And again, we can go much more than kilo. We can get a lot bigger than kilo. But if we move left, we get much bigger than our base unit. If we go right, we get much smaller than our base unit. Now, these prefixes have a very specific meaning. Okay, all of these prefixes have a very specific meaning. They're telling us how much of that base unit we actually have. So, for example, let's say that I drove 1 kilometer. Well, that's saying that I drove 1,000 meters. Another example, let's say that an ant weighs 1 milligram. Well, that's saying that an ant weighs 1,000th of a gram. So our prefixes are telling us how much of that base unit we're dealing with. Now, to convert between, or to convert within the metric system, I should say, we need to know where we start and where we end. So the best way that I can show you this is just through an example. Let's say that we have 125 centimeters, and we want to convert that into meters. So where are we starting? Well, we're starting at centimeters, and we need to go 2 meters. So we're starting here, and we need to get here. So we know that we have to move left. But how many spots do we have to move? So we're starting here at centi. We're moving 1, 2 spots to the left. So if we rewrite this, I have 125, and I'm going to put a decimal here after the 125. I think there's a lot of confusion. After a number ends, we often don't write a decimal, but there is a decimal there. So what's going on here is that, yes, we start at centi and we move 1, 2 spots. However many spots we moved and in whatever direction, that's the way our decimal needs to move. So in this example then, we move 2 spots to the left, so this decimal needs to move 1, 2 spots. So what we end up getting here then is that 125 centimeters is equal to 1.25 meters. Okay? One more example. Let's say that we have, let's do 1856. So 1,856 meters, kilometers, and we want to convert that into meters. So again, where do we start? Well, we're starting at kilometers and we need to get to meters. So we're starting here. We know that we have to move right to get to meters. So we're going 1, 2, 3 spots to the right. So rewriting this. Again, I'm going to put my decimal point here, and we had to move 3 spots to the right. So we're going 1, 2, 3. So there's our decimal point. Now we have a bunch of blank spots here. We have 3 blank spots there. What do we need to do with those spots? We need to throw in some zeros. So if we're converting from kilometers to meters, we're going to have here wow, what kind of number is that? Oh wow, that's a big number. We have 1,856,000 meters. Okay, so the big thing here, if we're converting within the metric system, is that we need to know where do we start and where do we finish. The number of moves and the direction of those moves tell us how we need to move our decimal point. All right, so next, moving on from simple conversions within the metric system, we can actually convert between the system that we use in the US here and the metric system. And this process gets a little more difficult than, just the moving the decimal place within the metric system conversions. For this, we actually have to use a procedure called dimensional analysis. Okay, and this process can be seen in this image right here. This is the basic format of dimensional analysis, and I would highly recommend that you write this down. It probably looks big and confusing right now. I'm going to try and explain it in this slide. However, I think through the sample problem on the next slide, it's going to make a lot more sense. So when we utilize dimensional analysis and we have to convert between the US system of measurement and the metric system, we're going to be given some starting value, okay? And that's going to be this guy here, what you start with, okay? And every value that we use is going to have some units attached to it, whether it's meters, whether it's inches, miles, whatever. Those units are going to go right here. Those are going to be the units that you start with. Now, the main key with dimensional analysis is that we need to go from these units that we start with to some units that we actually want to get to, okay? So let's say that we start with meters and we want to get to miles. Well, we have meters over here, but we want to get to miles over here. So how do we get rid of meters here? Well, basic mathematics tells us that if we multiply across a fraction, we can get rid of something by doing just that, multiplying across a fraction. So if we have meters here, we would have to have meters down here as well. And those would just go boom, boom, and cancel out. So the units that you start with would be gone. But then again, how do you get the units that you want? Well, if we cancel out those units that we start with, we have to have the units that we want up here, okay? Because basically once you cancel these out, once you cancel those units that you start with out, you're multiplying by 1, and anything multiplied by 1 is itself. So if we had meters up here, those cancel out. We had miles here. Miles times 1 is going to give us miles over here, okay? Now, the next big thing is we actually need to convert a number within dimensional analysis, and that's where this big idea of a conversion factor comes in. Now, this conversion factor is basically just a ratio between systems. So again, if we go with our example of meters to miles, well, we're going to have a ratio between those two to plug in here, okay? So we would have, I don't even know what the conversion factor is between meters and miles off the top of my head, but we would have something meters, and then we would have something miles up here. Okay? So then we just do the math. We're just multiplying all this out to then get something miles, because we wanted to go from something meters to end up with something miles. Okay? I know that's probably a little bit confusing, but I highly recommend that you write this down in your notes, and it's going to make a ton more sense. This process here, it's going to make a ton more sense on the next slide, where I actually do a sample problem for you. So our sample problem for unit conversions between the US and metric system is going to be how many centimeters are in 6 inches. Okay, so now if we take a look at our graphic up here, remember, we need to know what we start with. And in this problem, we're starting with 6 inches. That's the value that we know. Okay, so our units that we start with are inches. So that needs to tip you off that needs to go here. And that needs to also go here, because we need to get rid of inches. And what do we want to end with? Well, we know that we want to end with centimeters. So we know that our centimeters, we need centimeters up here. That's what we need to end with in terms of units. Okay, now how do we get from inches to centimeters? Well, we need this big thing here, that ratio that I was talking about, the conversion factor. And for this problem, our conversion factor is going to be 2.5 centimeters is equal to 1 inch. All right? So, what are we starting with? Well, we're starting with 6 inches. Okay? And now we're going to set up that dimensional analysis. So, we know that we need to get rid of inches. Okay, those are the units that we're starting with. So inches needs to go down here. So I'm going to write in inches down here. And we know that we need to end with, centimeters. Okay, that's what we need to find. So I'm going to write centimeters up here. Now we just need to plug in our conversion factor. Okay, if you take a look up here, we need to plug in our conversion factor up here. So again, we know that for every inch, there's 2.54 centimeters. So we're going to plug in 1 inch, 2.54 centimeters. And again, just basic math. If we're multiplying across like this, we know that our inches, boom, boom, are going to cancel out. So all we're left with are the units that we want. Okay? So from here, it's just all multiplication. So we're going to be multiplying 6 times 2.54 centimeters. And if my math is right, I believe that's going to give us 15 point, is it 1 or 2? I think it's 15.2 centimeters. Okay? So, again, with dimensional analysis, what are we starting with? What are we starting with? In this problem, it was 6 inches. Okay? And then from there, you need to look at what units are you starting with? What units do you need to cancel out? What units do you need to get rid of? In this problem, it was inches. What do we need to get to? We needed to get to centimeters, and you can see that here. Okay? And then what's your conversion factor? Well, I gave it to you in this problem, and I'll often give it to you in problems that we do, but you can also look those up. But in this problem, our conversion factor, or that ratio, was for every inch, there's 2.54 centimeters. Okay? So I hope that this screencast was helpful. Again, I highly encourage you to write this process down in your notes. And we're going to be delving into this and practicing this a lot in class tomorrow. So take care, physics students.